Thank you. Hi, so I'm Vaibhav Jain. I'm a senior software engineer at Red Hat and working on a Red Hat OpenShift AI project, more specifically on the model serving component. I'm a contributor on the KServe and the Open Data Hub community. And today we connect to discuss what to choose between model mesh and the model serving. I know that this abstract is little confusing. I will work much better next time. So I will try to make it clear, like the comparison. Okay, so a quick intro about the community. So KServe is an open source community which tackle the challenges to deploy the API models on the Kubernetes. KServe provide a standard model inference platform on the Kubernetes, and it also provide a standardized inference protocol across the ML frameworks. Okay, so KServe community provide the solution for both the single model deployment and the multi-model deployment. So single model deployment, I mean to say like one model per model server, whereas the multi-modal deployment meant to deploy multiple model inside of one model server. So model serving, also known as a K-serve component, is targeted for the single model deployment, whereas the model mesh component is targeted for the multi-modal deployment. So going forward, when I say K-serve, so that means single model deployment, and the model mesh, the multi-modal deployment. So KServe is built for the single model deployment, which built using the cloud native technologies such as Knative serverless and Istio. So KServe supports the modern serverless inference workload with the auto scaling, including the scale to zero on CPU and GPU. So as you can see in the diagram, like model server X deploy only a single model A, same as the model server Y deployed the single model B. Okay. Whereas the model mesh is built for the multi-model deployment. It is designed for the high scale, high density, and frequently changing model use cases. So as in port 1, single instance of model server X uses to deploy the model A, B, C, and D. Same as in the port 3, the single instance of model server Y used to deploy the model K, M, L, and P. Okay. So the multiple models are deployed inside the single model server. Models mesh have an inbuilt capabilities to intelligently load and unload the API models between the ports. As you can see, the model B and C are deployed on both port 1 and 2. Okay. So, and this all intelligent work is happened using this spatial containers that runs in parallel to the model server container inside the ports, that mesh container. So that's the container that handle everything. So in case of, so we have the Knative serverless and Istio to achieve this advanced feature, but in model mesh, everything is handled by the mesh container. Now the main question comes, what to choose between KServe and model mesh? So to make this comparison more clear, today I come up with a scenario-based comparison between them. Now the scenario first, like what to choose if I need to minimize the resource footprint and I have a lot of small models to deploy. So by design, KServe only support to deploy the one model per port. So if you have to deploy the N models, then you have to spin up the N ports. Whereas the model mesh support to deploy the multiple models in the same port. So even thousands of models could be deployed in the same port. So if you need to deploy an N models, then it could be possible that even you can deploy it in a single port. So very less footprint here. A test was conducted on the model mesh where the 20,000 simple string models are deployed over the two ports and the response was still within the milliseconds of latency. So model mesh is built for this. Now what to choose if I need an explainer, pre-post processing and ensembler capabilities. So a quick look about these terms. So explainers provide the ML model inspections and the interpretation. Pre-post processings are provide the processing capabilities around the data for the inference. And the ensembler means to combine the multiple models to solve the single problem. Okay. So generally users need to maintain like separate microservice for these capabilities. So they spin up the microservice separately, they push the data into it, and then once it has been filtered, then it goes to the prediction. But with Kaiser, provide these all functionality out of the box. We could directly configure the explainer, transformer, and ensembler requirement inside the case of CRDs. So user don't need to manage those external microservices by himself. Now, what to choose if I need a progressive rollout? So both Kaiser and ModelMesh support this feature. Kaiser uses the Istio to support the progressive rollout, whereas the ModelMesh using the inbuilt scaling capabilities. So that intelligent container, the mesh container that we discussed earlier, is the one that handled it for the ModelMesh. So as both support, so I assume it's a tie. But now, what to choose if I need my scalability? So now it's come like tiebreaker. So scale to zero functionality. So Kaiser uses the Knative serverless capabilities for it, which allow it to scale down the port to zero. Whereas ModelMesh have the inbuilt capabilities, which allow to scale down the model to zero. Now, there's a major difference in both the terms, scale down port to zero and scale down model to zero. So with Knative, Kaiser port replicas will bring down to zero if there is no traffic. Okay, so complete port would be shut down. Whereas in ModelMesh, multiple models are deployed in a single port. As we see in the first picture that A, B, C, and D, 4 different models are deployed in a single port. So we can't simply shut down the port if some traffic is not coming for a one model. So here, ModelMesh intelligently identify, okay, this is a model which is not used. So it just remove the replicas for that specific model only, not down the complete port. And yeah, and similar if we do the comparison on the number of the on the request. So if the high request come, then how they behave. So Kaiser uses the Knative port scaler to scale up. So Kaiser support the scaling on the basis of concurrency, and it's a user configurable. Whereas ModelMesh using the horizontal port scaler to scale up the port with all the models. Now, what to choose if I need to deploy the LLM? Now, this is a hot topic. Okay, so LLM, the large language models are usually gigabytes of size, and the multiple LLM models would not going to fit into the single port. Compilation of ModelMesh are worth to take. Sorry, complications of ModelMesh are worth to take when we have to load multiple models into the single port. So it's better to keep strict with Kserve here. So Kserve is like more cloud native. Okay. So there is no inbuilt intelligence. We can control it with the serverless and the Istio ports. Okay. Whereas ModelMesh have that inbuilt thing, so it's little complicated to configure. Additionally, the ModelMesh does not provide the support for the open source runtime for the LLM, which is required. Now, what's going on? So just before my presentation, Dan is also talking about the same thing. So, where the community is focusing currently towards the large language model. So multiple threads are going on, among which some are as to support the LLM model inference fetching its relations. So LLM models are large in size. So load them in the port will take a lot of time. So community is currently discussing the various options like how to solve or to minimize the port startup time. Okay. And there are more other threads like adoptions of the open inference protocol, which Dan was talking about, and the support of the LLM specific runtime. Kaiser 0.11.1 has just released. Now a very quick side-by-side comparisons after scenario based. So Kaiser, good for LLM. More flexible APIs, provide inbuilt capabilities of ensembler, transformer, and explainability. Single model deployment, simple, built on top of cloud native technologies, Knative and Istio. ModelMesh have minimized the resource footprints. Okay, it's ideal where we need to deploy the 100+ models into the single model server, and we have the small model obviously, and the multi-model deployment. Now, these are the quick links about the Kaiser community. You can join it on the Slack, GitHub, and through our website as well. Yeah, that's all.